Assalamualaikum warahmatullahi wabarakatuh and good evening to all of you. My name is Badrul Amin. So today I will present about my final year project with the title Polymer Electrolyte for Energy Storage Device Conductivity and Structural Studies. So here my name is Badrul Amin. Metric number is IIS 16006. My supervisor is Professor Dr. Siti Rohana binti Majid. So let's go. So this is the workflow of my studies. In my research, I make a hybrid of 5 materials, which are dextrin from potato starch, we call DEX, as stated in the diagram, CMC, carboxymethyl cellulose, a carbohydrate derived polymer, and then we have Spiro as a salt donor, as a charge carrier donor in this study, glycerol and ionic liquid. So the hybrid of 5 elements or materials is stated as the second system. The first system, which is on the below of the chart of the workflow in the diagram, excluding the ionic liquid, we have 4 elements. The blend of 2 polymers, which are dextrin from potato starch and CMC, with the introduction or combination with Spiro, a quaternary ammonium salt or commercial electrolyte, and glycerol as a plasticizer. So both systems are characterized with EIS, electrical impedance spectroscopy, to study the electrical behavior of the samples, XRD, X-ray diffraction, to study the angles that scattered from the samples, and FTIR, the study the Fourier transform infrared spectroscopy of the samples. So the method is used is a solvent casting method, which the polymer is blend until a homogeneous solution is achieved, and then dried in an oven and for 3 or 4 days at 60 degrees Celsius and peel off afterwards for further studies. So the first system is the mix of the 4 elements. The highest conductivity achieved will be used for the second system. Then the end of the workflow is dielectric data studies. So this is the first characterization, which is electrical impedance spectroscopy. We observe the sigma, which represent ionic conductivity versus weight percentage. So as you can see from the left graph, the highest sample is 35 weight percentage with ionic conductivity 1.99 to the power of -6. Later, when this weight percentage, this ratio is used afterwards in the second system with the addition of ionic liquid, the study found that it is able to enhance to 1.01 to the power -6. Although it is not much, but it is one of the objective in this research, which is to enhance the conductivity of So next, this is the graph obtained from the second characterization, which is FTIR, Fourier transform infrared spectroscopy. From the chart between both systems, we can see the salt or the charge carrier donor in this hybrid, which is ionic liquid and ammonium salt, the spiro, contributes to the ionic conductivity. The band from the graph is a proof that the salt have an action in the polymer electrolyte system. The bending represents a certain bond is having effect from the mixture of 4 or 5 elements in the system. So next, the last characterization before dielectric data studies is XRD. From XRD, X-ray diffraction, we want to observe the phase, the phases that exist in the system, whether it is crystalline phase or amorphous phase. The broad area under the curve, the better the sample is. The broader area under the curve represents the amorphous phase, while the peak or the mountains you can see from the colorful graph here represents the crystalline phase, which is not good for ionic conductivity. The higher tendency of the sample to become amorphous, the higher it have chance to get a high number of conductivity, which is successful in this study. As we can see from the previous slide, the ionic conductivity from the first system is only 1.99, almost 2 to the power of negative 6, and then becomes higher to 1.01 to the power of negative 6. As a conclusion, this study, which objective to find a higher conductivity from mixture or blend of 4 or 5 elements, is successful. So that's all from me. I hope you enjoy this video. Thank you for your time and energy. Stay safe.